In this question, he says two cards are drawn at random from a pack of 52 cards. The question is, what is the probability that either both of them are red or both of them are king? So we can understand first of all using the Venn diagram over here. We know that total number of cards are how much? 52 cards are there. And then probability of getting a red cards. So what you should know that how many red cards are there? Red cards are yeah, so say if I take n of a as the number of red cards, there are 26. And then there is a king also. Now, how many kings are there? We know that there are four kings, two red and two non-red, that is black, right? So if I say n of, was that n of b if I take, right, for the king. There are four king, but what we know that there are two cards which are red as well as they are red and that's their intersection, right? N of A intersection B, which are red and king, right? Two red king. So there are two in number. Now, what we have to find out is either, right? Either both are red or both are king. So that means either is what? A union B, right? So we have to find out A union B. So what I'm going to do is to first find out A union B. So if I say that this way, if I say that taking out, let's do the probability only directly. What I'm going to do is to apply P A union B instead of N. It should be what? PA, not NA, that's PA plus PB minus PA intersection B. Now, now one by one, we can find out these variables here. What is PA stands for? PA stands for taking out a red card, right? And we know that we have 26 red card from which taking out two red card is 26 2, and the total number of ways of taking out 26 cards, sorry, two cards from 52 cards should be what? 52C2. And what is PB stands over here? PB stands for the number taking out two king. So we have how many kings? Four kings, from which taking out two king is 4C2, and the total ways remains same, that is 52C2. Now what is PA minus, sorry, PA intersection B stands for? This is what? A red king. And we have how many red kings? There are two red kings. So taking out two from two is 2C2, and the total remains the same, that is 52C. So to simplify, what we can do over here is to take out this common, that is 1 over 52C2, and then we'll be calculating 26C2 plus 4C2 and minus 2C2, and that should, whatever it comes, should be the answer for this part. This question says a box contains 10 bulbs of which 3 are defective. Further, it says if a random sample of 5 bulbs is drawn, find the probabilities that the sample contains exactly one defective bulbs, right? And the second part is what? No defective bulb. So let's say if I take the number of bulbs is 10 over here, they are 10 in number. And how many of them are defective? 3 of them are defective, right? So remaining 7 must be non-defective. Now, our question in the first part is exactly one defective. That means from this 3 bulb, or sorry, ball here, and that's bulb only. From 3 bulb, 1 bulb is drawn, right? It's going to be exactly one defective. So the remaining, we are taking out how many bulbs? We are taking out 5 bulbs. So since one of them we are taken out is exactly defective and the remaining 4 is non-defective. So we can say that the required probability, let's say if I take P as the required probability, then it's going to be what? It is taking out 1 from 3, right? Multiplied and, right? That's the reason we place a multiply, and 4 from 7. And total possible way of taking out 5 bulbs from 10 bulbs is what? 10C5. Now 3C1 is 3 and 7C4 is what? 7 factorial over 7 minus 4, that is 3 factorial into 4 factorial. That whole divided by 10 factorial, and that divided by 10 minus 5 is what? 5 factorial into 5 factorial. So we need to solve this part. Let's see if I do it here. This is 3 into 7 factorial can be written as 7 into 6 into 5, and 4 factorial will get cancelled. I'm not writing that. This is 3 into 2. Below it is 10 factorial, which is 10 into 9 into 8 into 7 into 6. 5 factorial get cancelled. And the other 5 factorial you got 5 into 4 into 3 into 2. Now calculation is involved. This is 3 into 2, 6. I get this cancelled. And 5 into 2 is 10. This get cancelled. We have 4 2 times and 3 say 2 times. Finally, we are going to calculate this. The numerator is how much? 7 into 3, 21. 21 into 5 is what? 105. Below, we have what? 9 into 2, right? This is 9 into 2 is 18 and multiplied by 14. So that results to give you what? 252. Okay, this can be reduced further. 5 to 7. Yeah, this can be divisible, reduced by 3. So if I divide 252 by 3, what do we get? 84 below and above. So 105 divided by 3 is how much? 35. That's divisible by 7 also. So this is 7 5 times and 7 12 times, right? Yeah. So we divided 84 by 7. This way we got 5 by 12. Now let's move to the next part. And for the next part, no defective bulbs. That means out of the 5 bulbs taken out from 10 bulbs, none of them is defective. So what we can see that from 3 defective bulbs, there is 0 defective bulb taken out, and from 7, all 5 bulbs drawn are non-defective. So the required probability, let's say if I take PB as, then we can say that from 3 defective bulbs, none of them are taken out, and then we should put a multiply sign. From 7 non-defective bulbs, 5 are drawn, and the total ways of taking out 5 bulbs from 10 bulbs remains this only. So this is 3C0 is 1 only, and 7 factorial. This I'm simplifying. 7 factorial. This will come as what? 7 factorial over 7 minus 5, that is 2 factorial into 5 factorial. That whole divided by 10 factorial, and 10 minus 5 is 5 factorial into 5 factorial. Now, if I simplify it over here, this is 7 factorial can be written as what? 7 into 6, and 5 factorial get cancelled. That divided by 2. And then this whole divided by 10 factorial should be expanded. 10 into 9 into 8 into 7 into 6. 5 factorial get cancelled. This is 5 into 4 into 3 into 2. Now, same way we are going to reduce. This is divisible by 3 times. Right. And others like 5 into 2 is 10. So I'm cancelling this. 3 2 times and 4 2 times again. So this is what we are left with, 7 into 3 in the numerator. And below we are left with 9 into 2 into 7. Okay, into 2. So 7 and 7 get cancelled. 3 times. What did we get? 3 multiplied by 4, that is 12. So we'll say that the required probability will be 1 over 12 for this case.